Hi, and welcome to our pitch on SPARC FUSE, one data format to unite them all. Initially, we planned to work on a data-driven time series forecasting project. However, during the preparation stage, we faced a huge issue in terms of FAIR principles when it comes to working with SPARC datasets. For this reason, we switched the focus of our project a bit. So what's the problem that we've been facing? Currently, SPARC hosts more than 40 fragmented file formats with countless of subvariants in terms of internal file structure. As a result, researchers waste hours on converters and in writing glue code instead of analysis. The inconsistencies in formats break accessibility, reproducibility, and interoperability, and ultimately block cloud workflows. We strongly believe that FAIR data isn't really fair if it can't be streamed or scaled. So here's the solution. We developed SPARC FUSE, which is a tool that automatically remaps any supported file into a uniform chunked SAR store, or optionally also .met or .npc for legacy workflows. Currently, we support out of the box more than 80% of imaging and time series formats that we can find on SPARC, and we verified that across 38 different SPARC datasets. Why does it matter? With SPARC FUSE, we can cut the time needed to load a dataset from hours to a couple of seconds. That means that researchers can really spend the time on the science and not on data format wrangling. Also, we enforce interoperability out of the box. That means we have a unified file layout and researchers know what to expect to find in the file, and also they can use a single loader for any SPARC data. SPARC FUSE also provides cloud-ready chunks. By using SAR, we enable scalable streaming analysis on high-performance computing clusters and S3. Through all that, we boost FAIR principles because data becomes instantly accessible, interoperable, and reusable. Also, don't worry about metadata. It's always included. We include all SPARC metadata from subject ID to modality directly into the file, so it doesn't ship as a sidecar. We also add conversion-related metadata, such as source format, sampling rate, a mapping approach, you name it. All in all, we provide a self-describing output that is ready for analysis or publication. Now, how does it work? We use smart mapping with confidence scoring. That means we got handcrafted, expert-written mapping descriptors for common formats used in biomedical research, in particular in neural engineering. If there is no descriptor available, we use auto-mapping fallback. That means we score all descriptors and pick the best match for the file at hand. And don't worry, everything is transparent. That means that all mapping scores and methods used for the conversion are logged into the metadata. All right, how can you use SPARC FUSE? There are different options. The first option would be to use the command line interface or the Python API, which allows you to convert single files or entire SPARC databases with one function call. We also created a browser extension that adds a convert and download button to every dataset page on the SPARC portal. With that, the user can convert and download single files and even entire SPARC databases with one click. SPARC FUSE creates cloud-first outputs. That means you can stream SAR directly from S3 for zero-copy workflows on laptops, high-performance computing clusters, or Lambda. Overall, SPARC FUSE allows researchers to focus on science by skipping converters and proprietary formats and go straight to analysis. Finally, why SAR? SAR is a chunk storage format that means that data is split into tiny, independently readable and writable tiles. It's highly optimized for cloud use. That means the chunks live as S3 objects and you can stream just the bytes that you need. SPARC FUSE together with SAR is fully parallel ready. That means you can use tools like Dask, Ray, or SPARC to slurp chunks in parallel for speed. To benchmark that, we decided to compare the time needed to load 100,000 sample slice using SPARC FUSE with S3 support compared to a SPARC download and slice. We could obtain 100,000 samples in just 300 milliseconds using SPARC FUSE with S3, which is 33 times faster than when using a direct SPARC download. Finally, SAR is based on open specs. It's community-driven, language agnostic, and adopted by many institutions like NASA, UME SAR, and others. With that said, I'm wrapping up already. I would like to thank my amazing team, which made this project happen in just under 2.5 days of Codeathon, and we are really looking forward to seeing the community put it to use. Thank you very much.